Thanks for joining us for this Sky Above. Here's what's heading your way right now on this September episode. A trio of meteor showers will fly through the sky this month. We'll tell you when to keep your eyes up and the best time for night viewing. Plus, a new season arrives this month, how the decreasing daylight will impact your stargazing abilities. Plus, the moon is keeping things exciting this month. We'll talk about this month's full moon and who will be able to see the lunar eclipse this month. Welcome once again to our monthly show, The Sky Above, where we'll spend the next half hour talking about everything happening in the sky this upcoming month so you can plan ahead and know when to look up. September is here. Fall is knocking on our door. Hard to believe. We have some great sky watching opportunities heading our way. Let's jump right in. I am joined, as always, by Keith Crum. Keith, thank you for being with us today.
Thank you. Pleasure to be here.
You are a member of the Seattle Astronomical Society.
Yep.
Proud member. And also a NASA Solar System Ambassador.
Exactly.
A volunteer educator.
It's a volunteer organization. Yeah, started about 20 years ago. And it, they had a lot of stuff to put out there, but they realized they didn't have enough people to do it. So they started recruiting people like me to take the word out there about NASA.
I love it. Well, thank you for your expertise always. We'll start where we always do with our full moon. When does it arrive this month?
Full moon is September 8th. And and the new moon is on September 21st. September's a really interesting month for the full moon. It's a corn moon this month. Sometimes it's a harvest moon in September, but it's whichever full moon is closest to the equinox, which is on the 22nd. So we'll talk about the equinox a little bit later, I know, but that's why we call this month the corn moon, next month, October, the harvest moon. Sometimes they'll get switched.
Oh, interesting. Okay, well, that's an easy mistake to make then.
Yeah.
Okay, and this is a regular moon, shall we say, but we do have a super moon coming in early October, right?
Yes.
What's the difference between a regular moon and a super moon?
So this moon is the closest to the Earth that it gets. So it gets about 10% or so bigger and about 30% brighter. And the interesting thing about this year, this happens occasionally, it is a supermoon in October, November, and December this year.
Is it?
Yeah. So, you see these great pictures of it that look huge in the sky. It doesn't really look that much bigger, but it is much brighter.
You know what? There's something about a full moon. When you're out at night and you look up and you see it and it's full, it is stunning.
It is stunning, yeah.
Add the super. I'm sure it'll be great.
Yeah.
Okay, and then while we're talking about the moon, a lunar eclipse is also heading our way this month, but this is for some people, not for all. Here's a look at who can see it. So, who has a shot at seeing it this month?
Yeah, well, 77% of the world's population live in that zone there.
So Australia, New Zealand, Asia, so they'll have a good shot at this.
Eastern Africa, yeah.
And what does a lunar eclipse look like?
Well, the full blood moon, right there on the right, they call it the full blood moon. It looks very reddish orange there. Yeah, that's a great picture of it. Thank you, NASA.
So I think when we think of sometimes solar eclipses, you think the sun disappears fully, but that lunar eclipse, it doesn't disappear. It looks like it just changes color.
Yeah, the light's coming around the Earth and through the atmosphere and makes it have that color.
Okay, yeah. So book a plane, book a trip.
Go to New Zealand. I'd like to go to New Zealand.
I'd love to go to New Zealand. It's a great opportunity. Okay, Keith, let's move on. We love our meteor showers. Yes. We obviously had our exciting Perseids this last month. Did you get a chance to see it?
I did not. No,
what?
Unfortunately, no. I knew
you of all people? I'm shocked.
Why didn't I? I must have a good excuse.
It's busy. It's summer.
Yeah.
Okay.
Yeah.
But we have a couple other opportunities. We're going to call it the trio of meteor showers, which I know they're not quite as impressive as the Perseids.
But it shows that, first of all, September is my favorite month for star gazing because it gets darker earlier. Mm-hmm. And it's not as hot if you're in a hot place, like we go to Eastern Washington, it gets very hot there. So it's cooler, it's darker earlier. And this would be a great time to look for 3 different meteor showers. They're called minor showers, so they're only like 5 an hour.
Okay.
5 an hour?
That still sounds...
I'd like to see 1 an hour.
I know, five will, that'll do.
Yeah, that's right. So
let's go chronological.
yeah, okay, good. So the first one is September 1 through 5.
Okay,
right
so
at the
early
beginning of the month
September.
here.
Okay.
And then it's coming off from a comet, the tail of a comet called Keys.
Okay.
And the 5 an hour, and it's in the northeast.
Okay. So what would be the best way to view this if you wanted to try to see these? Which I'm sure will be true for these and then any other meteor shower as well.
Yep. Any other astrological thing that you want to see, you want, as we always say, dark sky.
Yep.
And you want, are you ready?
Yep, I'm ready.
Red light.
You brought a new red light.
Red light.
I swear, Keith, every month you show up with a new red light device.
I like this one. This one is a Army Navy surplus red light. And I really like it. You know, you can hang it like that.
Oh, that's nice.
It sits on like that.
And we'll remind anyone, for anyone who's just viewing your red light device for the first time, we use the red light because...
It doesn't ruin your night vision. Mm-hmm. So it takes 20 minutes for your eyes to get used to the light, and you want to keep them that way.
Yep.
If you use white light, like a phone in your face, you got to start all over with that.
Yep. So you are helping yourself by using the red lights. You'll be able to view the beauty of the night sky that much better.
Exactly.
Okay, so that was our first one. Then we have a second one. This is going to be a little bit later in September, correct?
September 12th.
Okay.
It's called the Epsilon Perseid meteor shower.
Okay.
So we've heard about Perseid before.
Right.
It's only called Perseid because it comes from the constellation Perseus.
Okay.
So it's coming out. It's the center of it's coming out of that constellation.
So not to be confused with the Perseids that we saw in August that were impressive.
It's a completely different unknown comet that it's coming from.
Okay. And when, where, how is the best time to view this one?
Same after
drill?
midnight.
Okay.
Most of them are after midnight.
Okay.
My wife and I found a good spot out in Duval at a Catholic church out there. Actually, they have a huge parking lot. It's very dark, and you have a good view northeast.
Oh, okay.
I mean, that's one if you're out in that area where we are.
Okay, or maybe head somewhere where the mountains don't get in the way.
Any one of the dark sky sites that we use for our star parties, Seattle Astronomical Society, those are good places to go.
Okay, and that's a little tease. We're going to talk about some stargazing events that people can join in on later on in the show. Okay, let's get to our final trio of meteor showers. This one's only 1 per hour, correct?
Yeah, this one's a little less. It is on September 27th.
Okay.
The Sextantids.
Okay.
It's from an ancient asteroid called Apollo. So this is an asteroid one as opposed to a comet.
Okay.
And
how would an asteroid and a comet differ?
You're going through the tail of debris.
Okay.
So it's just debris, whatever. That's what causes the meteor, right? Is the meteoroid is entering the atmosphere. It's then a meteor. If it makes it to Earth, it's a meteorite.
Oh, that's interesting.
Yeah.
Oh, the more you know.
So.
Okay, we got a lot of meteors.
Yeah.
Meteoroids, meteorites. Let's rapid fire. We have a couple other dates we want to just put on the calendar.
Yep.
Everything from the International Space Station passing overhead to some cool views of the moon and Saturn. Let's rapid fire get through those.
Good.
So the International Space Station.
Go out there at 10:30 on September 9th.
Okay.
It is marvelous to look at. It's super bright satellite streaking over there.
And you can see it with the naked eye.
Oh yeah, definitely. Yeah,
okay.
It's very bright.
So 10:30 p.m., correct?
I always wave.
This is p.m., this is in the evening?
Yeah, PM.
Okay, perfect. Yep. So we'll give a wave. We'll see if they wave back.
It just lasts 15 minutes, so it comes streaking across there.
Okay.
Like an amazing meteor.
Is it the type of thing that if you blink, you'll miss it?
No, not if you blink, but you got to be out there during that 15-minute time period.
All right. Okay, and then September 12th, we have a cool perspective of the moon.
Yeah, moon near the Pleiades cluster. This is a great binocular thing to look at.
Okay.
Between the moon and Pleiades cluster.
Okay.
That's a beautiful sight to see the two together.
Love it. Okay, and then finally on September 21st, Saturn will shine bright.
Saturn is at opposition, which means it's absolutely on the opposite side of Earth from the sun. So it's very bright because of that.
Okay.
And it's an interesting one this year because the rings are almost like edge on to us, just slightly not edge on, so that makes it really different. Looks like an arrow going through the thing or something.
Oh, neat. Okay, and this is, you're going to need binoculars or something for that,
Yeah,
right?
you need a small telescope or binoculars. Yeah.
Okay, so a great chance. We'll tease it again to head to a star party, which we'll talk about later.
Yeah.
Okay, let's get to another big milestone that we are hitting this month. I cannot believe it. Fall. Can you?
Yeah.
You got a pumpkin spice latte ready to go?
Yeah, that's right.
Okay, well, it's not just the lattes. We do have some interesting fall factoids. One of those, which I have never thought about, but it makes so much sense. The word fall, equinox in itself, is very self-explanatory to what we're seeing in the sky.
Yeah, equinox is from the Latin, equal night. So all over the world, we have the same amount of day and the same amount of night for the one day.
It makes so much sense.
Yeah.
And this is September 22nd, 11:19 a.m. That's when you can start having your pumpkin spice lattes.
Official time and date. Yep.
There we go. And so, yeah, like equinox, night. Equal parts day and night. We'll see sunrise and sunset around that 7 a.m., 7 p.m.
Yep.
Oh, my goodness.
12 hours. Yeah.
Oh, my goodness. And then, well, we won't get ahead of ourselves, but daylight saving in early November.
Oh, yeah. Yeah. Well,
We're not there yet, though.
Yeah. I have opinions about that, but we don't need to go down it.
We'll save that for another time. All right, Keith, anything else you want to add last minute?
No, I think that's good. That's a good summary. September is a great month for viewing the night sky. It's the best one as far as I'm concerned.
Well, and that's the thing is, in the summer we have beautiful daylight. We get those long days, especially in the Northwest.
Yeah.
But in the fall and winter, it's darker, which many people may complain about. But astronomers, that helps.
That's right.
Okay.
That's great.
All right. Thank you, Keith, so
Thank
much.
you.
Still ahead after the break, I have a new guest who is on a quest to inspire young people, get them excited about science and astronomy. Anisha joins me to talk about her research she's conducting into telescopes, exoplanets, star viewing, and more. You are going to be so impressed by her. Stay with us. Welcome back to our September episode of The Sky Above. I have a new guest joining me right now, Anisha Bajaj. Anisha, I have to say I am so impressed with you already. Your passion for astronomy. You, at just 16, junior in high school, have already done more than, gosh, many people do in a lifetime. We could sit here all day and talk about it, but let's go through some of the spark notes of your astronomy passion.
Yeah, sure. So I'm the president and founder of the Youth Astronomers Society of Seattle.
Which acronym?
Yes.
YASS?
Yep.
We got to say it fun. Yes.
Yes, it's a lot of fun. Yeah. And we're basically just a group of like high schoolers who all have the passion for astronomy. We're under the Seattle Astronomical Society. And then our main goal is to make astronomy more accessible for people our age.
Yep.
So I have a couple things I can talk about for YAS.
Yeah, let's hear it. Girl Scouts, right?
Yeah. So we go to some of the SAS star parties. I have a telescope, and then like I can teach people how to use it. I can like show people the night sky, and then like we also like learn a lot. There's so many like different astronomers that go to those star parties, so it's a lot of fun. And then we also host our own YAS star parties, usually in Mercer Island, so you should come to one.
I love that. Okay, and your whole thing is youth, right?
Yeah. So we try to inspire like the younger kids too, like the elementary, middle schoolers, and a way we do that is through partnering with Girl Scouts.
Yeah.
We go to a lot of their events and like teach about astronomy. I have like a presentation and like an activity that they usually really enjoy. So it's a lot of fun. I just try to get them curious about STEM and like science. And then we also, I think the main thing that YAS does is for people my age, a lot of us have our own like STEM projects that we're working on. So if they're astronomy related, like YAS can help. We've already helped with research papers, writing professional research papers. We've like won awards, won scholarships, and all that.
Amazing.
It's been a lot of fun.
Oh, amazing. And Anisha sent me a whole list of topics of things that you have already researched. And I want you to just flex that muscle of your brain, and I want to hear all those things. Let's start with exoplanets. You won an award for your exoplanet research, correct?
Yeah, it was through the George Mason University. So exoplanet research is on really high demand right now because people they want to know if there are other planets outside of the solar system. So they also want to know if there's life. I sadly didn't discover any life, but
I would be impressed if you had.
I did find something interesting using the transit exoplanet method, which is what you can see right now. Basically, I used transit photometry, and it measures the light that the star emits. And when there's periodic dims in the star, we think that there's an exoplanet going in front of it. So then we can plot that actual dim and then see it, which is what I did too. I plotted the light, and then we can tell if there's an exoplanet or not. So the one that I studied is called TOI 3777.01, and
a nice nickname.
Very, very easy to say. And I think what I discovered is it might have been something called a hot Jupiter planet, which basically means it's really big because Jupiter's a really big planet, and then it's really close to its star, so it's super hot. And by analyzing the light curve and the reduction of the light, I could find its size, I could find its orbit, and it's the period of it, and then I kind of figured out that it was a hot Jupiter.
Wow.
And the group that I was doing the research with, there were 60 to 100 other students, and we all did our own research, so it was a lot of fun this summer.
Oh my goodness.
Learning about exoplanets.
That's incredible.
Thank
okay,
you.
well, I'm ready for you to discover something out there and keep that going. Okay, you've also researched different ways to view stars. What do we mean by this?
Yeah, so on a high level, I think what most of us are familiar with, it's visual astronomy, which is basically just using a telescope or binoculars to see the sky. You don't need that fancy equipment. All you need to do is see Saturn's rings, for example, or look at the moon in detail, see its grooves and its craters and all of that. It's beautiful. But then beyond visual astronomy, there's other methods that we can use too, and I'll talk about a few of them.
Let's hear it.
So they use different types of instruments to measure attributes of the object in the sky. For example, if you choose a random star that you can see, it has a specific type of light, specific amount of light, specific size, chemical properties, all of that. And you can't really tell just by looking at it. So, for example, spectroscopy, that's a method that we can use to figure out what the star is made of. So
that's this right here, this visual here. Okay, so what are we looking at here?
So basically what spectroscopy is you add a special filter to the telescope, and then it spreads out the light. It breaks apart the light into a spectrum, or the rainbow. You can see that there. And then in that rainbow, there are gaps of the light. And then those patterns of the gaps, they correspond to a chemical element on the periodic table. So each element, hydrogen, oxygen, sulfur, sodium, they all have their own specific pattern. So then what astronomers do is they match the pattern that the star gave to the chemical property, and then they can figure out what the star is made of.
Oh my goodness. Anisha, you are so impressive.
Thank you.
What made you fall in love with astronomy?
I honestly, it started with the shows that I've watched. I like Interstellar, that's my favorite movie. But then I went to a SAS star party a few years ago, and I saw my first look of Saturn through, I know exactly what telescope it was. It was a Dobsonian telescope, and it was amazing. It was so cool. I met new people, and then ever since then I've just been really involved.
How old were you?
I was 13, 14.
Oh my goodness.
Yeah.
I'm so impressed by you.
Thank you.
What do you want to do? Do you know? Do you have it figured out?
No idea.
That's okay.
No.
That's okay. You've got lots of time.
I have another really big project I've been working on for
Okay, let's hear it quickly,
days.
yeah.
It's speckle interferometry. So that's another advanced viewing method.
Okay.
It's basically, I'll give you kind of a visual. So when you look through a ground-based telescope, what you're looking at is an image, but you can't really tell that there's a bunch of atmospheric disturbance between the actual telescope and then in the sky. So what speckle interferometry does is it's a computer-based program that reduces the atmospheric disturbance. And then, for example, a lot of the stars you see in the sky, you see thousands, but many of them are actually double stars. They're two stars orbiting each other.
And that's what we're seeing here?
Yep, that's right there. And then even with like most observatory telescopes, you can't really tell the really distant double stars. You can't really distinct them. But using specular interferometry in a powerful telescope, you can zoom into those and you can take what looks like just a single point and then use the special computer software to take out the atmospheric distortion. And then as a result, what seems like one star can be resolved into the two stars. And that's called a binary star system. And then I've used both of those methods, spectroscopy and specular interferometry, in the past year, and it's been a lot of fun learning and like making new discoveries and adding to discoveries too.
Oh my goodness. The world and beyond is your oyster, Anisha.
Thank you.
Thank you so much for all of your insight. I'm going to have you stick with me. Keith is going to join us after the break, and we're going to talk about a couple other little interesting things that we can view in the sky. One of them, it's called dust, but I swear it's cooler than that. We'll talk about zodiacal dust coming up. Okay, so this is a cool thing that you can see at sunrise and sunset. It's dust, but you guys just helped me out here. Keith, Anisha, I said zodiacal. Say it for me.
Zodiacal.
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 Yeah.
Thank you for your knowledge. What is this?
You want to start?
Well, yeah, it is dust that orbits the sun, and they call it zodiacal because it follows the path that the zodiac constellations follow.
Okay.
So that's why it's called zodiacal dust.
Okay, that makes sense.
So it's made from asteroids and from comets, and it's visible at sunset and sunrise.
Okay.
Kind of looks like sunset and sunrise, but it's different. You know, it has different colors. Yeah, there's a graphic showing how it moves through space around the sun.
Okay.
You can actually discover exoplanets through zodiacal dust. That's called zodiacal planetary discovery. And if you like look at a star and you can see the dust, you can see like those rings or like clusters or like shapes. And what astronomers think is that those can be exoplanets.
Oh my goodness, incredible. Okay, so we'll keep our eyes peeled for that as we look forward this month, right?
Yep.
All month long. Okay, and then both of you are members of the Seattle Astronomical Society. Anisha, are youth as well.
Yep, there's a star party coming up on the 6th.
Okay, perfect, September 6th, but so many star parties are coming up. We'll just quick pop those up. We've got Shoreline, Bonnie Lake, Duval, Snoqualmie Point Park, a lot of different events heading our way this month. This is a great opportunity to get out and meet people like Keith, people like Anisha, get excited. Hey, maybe you'll be like Anisha and look through a telescope and you'll just be hooked from there on.
That will happen.
That will happen. Okay. Thank you both so much for your time. That does it for us on this September, I can't believe it's September, episode of The Sky Above. We will be back with you next month. Thanks for being with us.